All right, can y'all see and hear me okay?
Hear you, yes. See you, no.
Can you see the whiteboard? Can we see the whiteboard? Cool. So if someone asks you how fast you're going in your car, and let's say you're driving through a school zone, so you're going 20 miles per hour. So that's what you're supposed to be going in a school zone. So what we're seeing is that we have a distance over a time, and that's what our speed is. If you go to Canada or you go to Europe, it's going to be kilometers per hour, because they use kilometers, not miles. The US is weird like that. And so let's say you're going 20 miles an hour. And let's say the school zone is 3 miles long. So if you have to go 3 miles, and we want to know how much time that's going to take, we can plug all of this in and solve for the time. And here's our formula. Speed is distance over time. So we have speed. We're going 20 miles per hour. We're going to go 3 miles. And we have X amount of hours that we don't know how long it's going to take. And we can put a 1 here if you want to. So now there's 2 ways we can think about doing this. There's the long algebra way and there's the short algebra way. You want to do both? So the long way we have our 20 miles per hour, 3 miles, X hour. We send the X over. For X hours. And then we divide by the 20. So what happens is that we have miles divided by miles. So those miles cancel, and we're left with hours. That should be 3, excuse me. So if we do 3 divided by 20, what do we get? Point 15. So it's going to take you 0.15 hours to go through this school zone. And we can do a little crash course unit conversion to figure out what that's something meaningful. So we have these 0.15 hours, but that doesn't make any sense. So let's convert that to minutes. So we have hours. So we need to cancel and put hours down here. And we'll put minutes on top because that makes more sense. So in 1 hour, we have 60 minutes. Multiply these 2. And take you 4.5 minutes to get through the school zone. So the short and dirty way to do this anytime that you have to solve for x on the bottom, you can just swap those two. So you have x is equal to 30 miles over 20 miles per hour. If you don't want to go through the whole algebra, just remember if x is on the bottom, just switch it. Or what else you can do is you can make a triangle. So speed is distance over time. So if you need the time, you're going to put distance over speed. Whichever method works best for you. Y'all want to do another example? We can do one more. All right, you picked. Do you want to find speed, distance, or time? Well, we did time and speeds. We can do another time one. Okay. Let's see. Let's say a beam of light is going 3 miles per second. And it's traveling for 100 meters. And we want to know how long it's going to take to get that 100 meters going 3 miles per second. So we want time, so we'll put distance over speed. So we'll put our 100 miles, let's just change that to meters, it's meters. 100 meters divided by our 3 meters per second. And we get 33.3333 seconds. So it takes about 30 seconds to go 100 meters if you're going 3 meters a second. All right, we do a speed one. Let's say you're running and you run 7 miles because you're a badass in 2 hours. We'll give you a better time than that, maybe 30 minutes. If we want to know the speed, we'll do the distance over the time. So 7 miles over 30 minutes. Click. So we're going 0.23 miles per minute. And then we can convert that to miles per hour because that's more useful. So we don't want to get rid of the miles, just the minutes. It's already on the bottom. So we'll put it on top to cancel it. And we'll put hours on the bottom because we want miles per hour. 1 hour, 60 minutes, multiply the two. So then that means you are going 14 miles per hour, which is pretty fast if you're running. Do y'all like me to talk about the graphs a little bit? Or do we feel good about the graph? I'll go over the graph a little bit. So majority of the time, anytime you ever get a graph, time's going to be on the x-axis because it's always independent of whatever is going on because you can't change time. We have distance on the y-axis. So let's say this is home. Put a little house there. And let's say you start going for a walk. And so over time, you're getting a larger distance away from home. And let's say about here, you decide you want to start running. So you're going to be going more distance in shorter time. So your slope increases from what it was. This is a large slope, that one's a short slope. Let's say after you're done running, you get tired and you stop for a break. So time keeps moving, but distance stays the same because you're not moving in distance, but time is still passing over. So if you see a straight line, that means you're not moving. And now that you're rested, you start to walk back home. If your distance is decreasing from wherever you're starting from, if your distance is decreasing, that means that you're getting closer. As I walk closer to the table, there's less distance between me and the table. The distance goes down. And so if you want the average speed, you just find the slope. Like in our video, there's an example where this kid does something like that. And so let's say we want the average speed from A to B. We'll say this point is 0, 0. We'll say that this one is 5 and 10, just arbitrary numbers. And we'll plug in our slope formula. y2 minus y1 over x2 minus x1. In this case, 10 minus 0 over 5 minus 0. So our average speed divided by 10 would be 2, whatever units that we would choose to be using for this. Does that help? there anything else you want me to go over? Okay. Well, happy Monday. I'll see y'all later.